Welcome to the part 2 of the QCAA 2023 Mathematical Methods External Assessment Multiple Choice Questions. This time we're going to have a look at paper 2, the technology free paper. Let's start with question 1. If f of x equals sine 3x, determine the value of f dash pi on 8. So for this question here we need to first of all know what the derivative is. So if I write down the derivative of the function is sine 3x, so it's going to be 3 derivative of sine is cosine of 3x. I can simply then use my calculator. Simply putting my calculator, this particular function should give me this 1.14, which is B, 1.148. All right, now question 2. Question 2 is the probability of hitting a bullseye on a standard dartboard is 1 in 1,250. What is the probability of hitting a bullseye exactly once in 10 attempts? So we're going to look at the probability of success being 1 in 1,250. The number of trials in this case is 10, and we're going to use our binomial distribution formula. Probability of x equals 1, 10 to C1. We only want to find out the probability of hitting the bullseye exactly once. So 1 out of 250, p to the power of 1, multiplied by q to the power of 10 minus 1, which is 9. So failure in this case is going to be 1,249 divided by 1,250. So that's all we need to do for this. We're not asked to actually calculate what the answer is. If we were, we would just use our binom PDF function in our calculator. So this one here, if you look carefully at that, matches up to C. I believe it's C for question 2. Okay, question 3 now. In a certain normal distribution curve, 95% of the area lies between the values of 50.32 and 113.68. The mean of the distribution is 82. So they give us those two values and the mean. We're asked to determine the standard deviation. So for this one, I'm going to start with a bit of a diagram here just to explain what I'm thinking. And here it is. I've got the distribution here, 95% of that area between 50.32 and 113.68. Now I can either work with this value here, the 50.32, or I could work with the 113.68. I'm going to choose to work with this value here, call this Z1 if you like, and I know that 95% of the area is going to be represented by a value of negative 1.96 for our Z-score, standardized Z-score, and this is one of the formulas that's not on your formula sheet that you should remember for the external exam. There's about 5 different formulas, this being one of them that's not on the external exam. Remember that. I know my x value is 50.32. They give us the mean, which is 82, and I've just got to rearrange that to find sigma, and I get 16.16 on my calculator. I could have used my calculator a different way. I thought this was probably the easiest in the exam. Of course, I wouldn't be actually drawing a diagram like this. I'd probably just do this last 2 lines of calculation there if I needed to show some working out for that. But that is answer A for question 3. Question 4 is the displacement in meters of a moving particle given by d equals e to the 0.5 t minus 1, where t is time in seconds. The acceleration in meters per second squared of the particle when t is 4 is equal to. So you need to know that the derivative of the displacement function is going to be your velocity, and the derivative of your velocity is going to be your acceleration. So knowing those two things to begin. I can then work out, if you like, the first derivative of the function 0.5 e to the 0.5 t, and the second derivative or acceleration 0.5, well, it's going to be squared e to the 0.5 t. There's my acceleration, if you like. I can then go ahead and use my calculator. I could have also done this in the calculator. It was a simple derivative, so I've just typed that in there in the calculator and substituted 4 in for the time, and that gave me an answer of 1.8473, and that was answer D for question number 4. So question 5 is a fairly straightforward calculator question. Solve ln x plus ln 3.7 equals ln 9.25. Solve that for x. Now I'm using TI-84 calculator here, but you could use whatever solve program you wanted to on this. I've just used Solver here to set up my equation and solve for x, and I get 2.499999, which is rounded to 2.5, which is answer C for question 5. Moving on to question 6, we're asked to calculate the derivative between a and 5a of 1 over x plus a. This is a simple calculator question where really all you should be typing into your calculator is the integral between 5a and a of 1 over a, that's x, 1 over x plus a dx. Now in our calculator, the TI-84, that should then spit out the answer of 1.09886, and that is answer D. You could of course do that by hand as well, but I think using the calculator is probably the easiest way for that one. So there's a screenshot of the solution there. So question 7 is the distribution of a certain sample proportion has a mean of 0.7 and a standard deviation of 0.2. Determine the sample size. So we're given, in this case here, p hat is equal to 0.7. We're also given the standard deviation is 0.2. You should know from your formula sheet that that standard deviation is equal to the square root of p outside of 1 minus p over n. That's on your formula sheet, and then you can use your calculator. In this case here, just using equation solver, I get a value of x equals 525, which is answer A. On to question 8 now. Question 8, the number of koalas in a certain conservation park is modelled by n equals 15 ln 7t plus 1, where t is greater than or equal to 1. And t represents the time in years since the park opened. There were 20 koalas in the park when it opened. To determine the approximate rate of change in the number of koalas when t equals 3. So this is a straight up calculator question for the TI-84. It's math 8, I believe, NDerive, and we're simply just going to enter this into our calculator to generate the answer. We're just going to type in the function, and x equals 3. In this case, we get an answer of 4.7. Now, what's that closest to? When you round up, that's closest to 5. So answer D for question 8. Okay, question 9. If f of x equals e to the 3x outside of x plus 1 all squared, and the derivative is equal to a e to the 3x outside of x plus 1, determine the expression for a. So this one's a bit of a tricky one here. I'm going to start with finding the derivative of the original function. So what I'm going to use for that one is I'm going to actually use product rule. So there it is there, product rule. I've got U, U dash, V, V dash, and I can put those together here. So I've got an expression here that I can see there's a common factor of e to the 3x here, and then there's an x plus 1, and there's 2 of the x plus 1s over here. So I might be able to factorize this to make this a little bit simpler. So if I factorize the e to the 3x and the x plus 1, it should look like e to the 3x outside of x plus 1. And then I've got a 2 left here, so I've got 2 plus, I've taken out the e to the x, I've got a 3 here, and I've got one more x plus 1 over here. So that doesn't really look like it's in the form that we wanted, which is a e to the 3x outside of x plus 1. But I'm happy that I've got an e to the 3x and an x plus 1 here, so I think I'm on the right track here. And if I rearrange it, I reckon that this part here would be my a. So if we tidy that up a little bit, we've got e to the 3x outside of x plus 1, and then we've got 2 plus 3x plus 3, which, and again, if I simplify that further, gives me 3x plus 5 in that bracket. And if I bring that out the front, just rewrite it a little differently, I've got 3x plus 5 e to the 3x x plus 1, which, if I look at the question again, that is, I guess, my a. That's the in the form that was given in the question. Now, if I go to the multiple choice answers, a corresponds to answer A, which is also 3x plus 5. So question 9, answer A. Okay, question 10 here, bit of a long one, but we've got the student is trying to determine which subject they perform best in compared to other subjects. Results from recent tests for subjects A to D are shown. Assume that the student's results in each subject are normally distributed. So we're going to use our Z-scores here to compare these, and I didn't have a shortcut method of this, so I've just going to go straight up and write them all out one by one and then compare them at the end. And there they all are there. I've written them out, put them in my calculator to work out, standardize them all using Z-scores, and I can see that B 0.76 looks like to be the largest number, in this case the best result. So that would be B for question 10. And that is it for the paper 2 of the 2023 Math Methods External Assessment Multiple Choice. Thank you.